A very good evening to one and all who has joined us in this online meeting in the second session of the fifth day of this faculty development program that is sponsored by All India Council for Technical Education. And our honorable guest for today's session is Mr. Rohan Digital, who is working with Tata Alexa as a regional manager for Asia Pacific region. Dange sir, it is really a matter of honor for us to have you as our expert speaker today. And I would also like to inform all the attendees here that in part one of this faculty development program, our today's honorable resource person was awarded the best speaker award for that for part one of faculty development program. So so let us introduce our honorable guest for today's session. Mr. Rohan Digital, sir, as I mentioned, is working in Tata Alexa as a regional manager for Asia Pacific region. He has around 10 years of experience in business development, predominantly in manufacturing domain. He has worked in different organizations like PwC, KPMG, Kirloskar Wright Water Solutions, and Tech Mahindra before joining Tata Alexa. Now in Tata Alexa, he is working as a regional manager for Asia Pacific region, wherein he is responsible for business development in areas like rail, automotive, media and communication, then healthcare technology. Thus, Mr. Dange has a very wide experience of working in different domains and cultures as well. During his tenure with Tech Mahindra, he was also responsible for international sales, and extensively he has traveled to various geographies like South America, Middle East, United Kingdom, and ANZ region. He has done MBA from Symbiosis International University and engineering from Nagpur University. In his free time, he likes to read newspapers, watch football, and drive. He intends to continue his education in energy and environment domain. So we are really glad to have you as our expert speaker, Dange sir, and we will now request you to please start your session.
Yeah. So thanks, Abhijit sir, for this introduction. It is indeed my pleasure and honor to be part of this faculty development program. I really look forward to the session. And in today's session, I would like to touch upon the 2 points, predominantly the engineering education in practice. I mean, in today's corporate world, how you can put your engineering education into practical use. And second, interesting and different topic that I would like to talk about is creative thinking. Because nowadays we are, seeing a lot of demand is for, creating thinking and this I'll say creativity plus engineering, that kind of combination is in demand. So these 2 things I would like to speak upon. So with that, I'd start my session for today. Meanwhile, during the discussions, if anyone has any doubts, please feel free to interrupt me. I'll be more than happy and will try my best to resolve the queries raised by you. So, having, worked in different domains, I just want to start the session by presenting the employer perceptions of today's engineering graduates. Typically what we have found is, engineers, they have a, I'll say they lack the business acumen side, which is very much required in today's corporate world. That's what I mean by saying technical arrogance. Then what we have seen is there is a lot of practical application know-how, means they lack the understanding of the manufacturing processes, and from the day one, everyone want to be managers rather than working and dirting their hands on ground. And communication skills is one of the area of concern. Because we typically found that engineering graduates are kind of raw in their language skills, not having a very fluent communication skills, and last but not the least, they are more into individualistic mode, and they don't gel that great in working in the team environment. So this is the employer perception about today's engineers, and a quick action needs to be taken so that the engineers are more, I'll say they are in sync with the today's engineering trends. Going to the next slide, I mean, what can be the possible solution of the problems that I have discussed in the previous slides. So, to on a very high level, I'll say that maybe they should they should really work on ground during their engineering education. They should be really encouraged to do some internship programs in industries spanning 2 months after every after every semester, if that is possible. The active learning on ground and theoretical learning should go hand in hand if today's engineers needs to be employable. That is very important, I would say. Then definitely whatever they have learned, those mathematical and scientific concepts, they should understand the use cases. I mean, just to give an example, I mean, many of the engineers during their electrical engineering, they say, for example, learn Kirchhoff law. But I know for sure that they don't know where that Kirchhoff law would be used, or if at all, in which application that law was used. And so only theoretical, know-how is there regarding Kirchhoff law, but even that curiosity is not there in today's students to understand where on ground this theory that we have learned is applicable. Everyone is just focusing on the kind of jobs, the packages, but not really on the knowledge that they should gain during their tenure of engineering education. Definitely, another important point is close interaction with the industry. They should go and meet the industry people, try to understand what are the trends and technologies which are in demand in the industry. And definitely, I'll say not only use information technology for social media, but use information technology to understand the next gen technologies, which will make them more employable in today's market. And yeah, and faculty should work with them as their mentors and coaches, and should have a very strong relationship with them. And maybe faculty, the onus is on today's faculty to really understand that each student is different, each student have different learning needs, each students have different area of interest. And so definitely faculty should mentor these engineering graduates and help them pursue their area of interest. Yeah. And yeah, so next topic is curricular upgradation. I think it's a two-way traffic. Not only that students should be expected to do all the things. The onus is on institution as well in terms of upgrading their curriculum. So the curriculum should not only talk of technical, because to really excel in today's world, only technical knowledge is not sufficient. The social, economic, safety, legal, all these angles. I'm not saying that we turn engineering schools into management schools, not really, but that flavor should be at least there in one of the semesters, so that people or students should have 360-degree view of all the different topics which are equally important and technical. That was my point of view, by saying that we should include other aspects as well while concentrating on the technical aspects. And as I said earlier, hands-on experience, so building those state-of-the-art laboratories. For example, IoT is one of the areas which is seeing a lot of industrial demand in automotive and manufacturing process. But people only understand IoT from internet and only theoretical classes. What is IoT on ground means, that people don't understand even after getting you know after their graduation. So certain IoT labs should be set up by the colleges. They should do investment, they should do collaboration, and they should definitely help students to understand the practical aspects of the topics like IoT, artificial intelligence. I'm just giving an example, not really that this should be the only areas of focus. Yeah. So any questions till now? Anyone have any question? Yeah, so I'll again move to the next. So yeah, so now if I had to say that what are the engineering opportunities in the in the coming years. So I have done a lot of intense research, I would say, because the opportunities that would come becomes our target market as a sales and business development personnel, because our offerings, when I work in industry, our offerings should be very much in relevant and sync with what industry is asking. So these are the different opportunities that would be for engineering students in upcoming years. That is big data, cloud computing, system integration, augmented reality, simulations, Internet of Things. And specifically, if I talk of the manufacturing, energy utilities, if I talk of automotive, then the Industry 4.0 application in that robotics, human-machine interface, sensor, sensor-based analytics, monitoring tool, instrumentation, control systems are some of the areas which are seeing a good amount of traction. And trust me, major R&D spend of any organizations are predominantly in this space. And I'll say why these technologies are in demand. The reasons are, because implementing these technologies would improve the productivity of the organization. Their machine efficiency would be improved by at least 20%. Definitely, it will bring in the process optimization, and process optimization and resource utilization go sync. So yeah, so resource utilization would increase. What would it really reduce is the production cost, the resource wastage, the rework efforts, and the machine downtime. Machine downtime has a very significance in automotive and industrial and manufacturing domain, because even a machine downtime of 15 to 20 minutes means I'll say, yeah, millions of dollars lost in for a company. So that is the significance of machine downtime. So every company, trust me, is literally targeting zero machine downtime. And to achieve that, these are the certain tools on which they are relying upon. So yeah, so these are the opportunities that I foresee would be the in the at least upcoming decade. Upcoming decade, these would be the very relevant areas. Yeah, and coming from the automotive background or presently working in the automotive space, these are these key areas where we are seeing that there's a lot of, demand coming from the research and development institutions and the technology companies, OEMs, and the other support tier ones, tier twos, engineering companies. So I'll do a deep dive in the subsequent slides, but just a high level overview would be the vision based terrain mapping system, intelligent systems. Telematics is nothing but connected cars kind of solutions, digital simulations and research. So if you had to check the safety of a vehicle, no more you require a digital, you require a physical vehicle to do all this testing. Everything is now shifted to digital simulations and research, big data and machine learning. Yes, a lot of data is being now generated by vehicles, and mere analysis of that big data would help in predictive maintenance. Not really the case that your machine would have a downtime and then you will understand what is the fault. The intelligent systems would tell you in advance that in the next say 50 or 60 kilometers there is a probability of some fault occurring in your car. So that's how the systems have become very intelligent. System engineering, system integration, validation, human machine interface, of course, and electrification. This electric vehicles is going to be a big topic post 2025, and every country is now targeting shifting from fossil fuel powered vehicles to complete electrification vehicles. So I think electrification of vehicles is one of the very, I'll say, upcoming areas in today's automotive world. So if I had to bucket all these things into major three trends, then I'll say it's electrification, connectivity, and autonomous operation. Yeah.
Sir, I had a query actually.
Yeah.
While you mentioned all these key areas of engineering,
Yeah.
electrification, connectivity, and autonomous operations, we would also want to understand from you as to what kind of educational background, I mean, whether in electrification, students from electrical engineering are preferred or students from electronics are preferred. So what kind of educational background would be supportive? At the same time, what type of skill set will be, will be preferred?
Yeah, Abhijit sir, actually in these domains, no, honestly speaking, I'll say every engineer has a role play, because car is a domain wherein everyone is required. So for for preparing the softwares in the electric vehicles, IT and computer science people are required. For all the electrical developing electrical systems, electrical engineers are required. For for the design of the vehicles, and all those mechanical aspects, mechanical engineers are required. As far as civil and other engineers are required, they also have a role play to play, because all these interiors of the vehicle, all this user experience, there those engineers would be required. So the good thing about this domain is, even if it looks like a mechanical engineering driven domain, it's not the case. Every engineer from different background would have a role play to play for electric vehicles. And again, if we talk about the background, we understand that people who are engineers would not have an end-to-end knowledge about the overall systems and subsystems. But even a relevant industrial training for 2-3 months, or some specialized course, if they have done during their engineering education or post engineering, even if they have invested some time to understand the domain, then the industry is more than open to hire such people. Yeah. So I hope that that answers the query.
Yes, yes, that answers the query. Thank you so much.
Okay. So if
And if I may interrupt further, I would like to, I would like to share this with all the attendees that Mr. Rohan Dange sir is also, Mr. Rohan Dange sir is also, he keeps on advising Symbiosis International University, Symbiosis Pune, when it comes to designing course and, accommodating the latest trends of engineering into their course. So I think that if any of the faculty members attending here would be interested, you can always push your queries, because he will be more than happy to answer the queries. Yes, that would be all, Pawan sir. Thank you.
thanks, Abhishek sir. So if I talk of electric vehicles, electric vehicles is a vast and a vast ocean, I'll say. But if we bucketize the major offerings from the electric vehicle domain, then that would be the battery management system, which is the heart of any electric vehicle, charge control modules, then supervisory control unit, electrical vehicle control module, motor control unit, DC to DC converters, onboard chargers, and range extenders. So just to give just a high level overview, so range extenders are nothing but if your vehicle is capable to run 300 kilometers on a single charge. So now every OEM is doing this R&D, how to extend that range, say from 300 kilometers to 400 kilometers on a single charge. Onboard chargers. So onboard chargers are nothing but when the vehicle battery is down, how we are able to quickly charge the electrical system so that the vehicle is up and running. DC to DC converters, because every subsystem subsystem device would run at different voltage in an electric vehicle. So those DC to DC converters would be required so as to suffice the need of each of the subsystem device for their voltage requirement. Motor control unit. So electric vehicle are, as you know, it is a completely motor driven unit. So controlling that motor, acceleration, braking, so all those functions are driven from motor control unit. And then this electrical vehicle control, supervisory control, charge control are nothing but the control systems which govern the electric vehicles. And these are the, I'll say, 6-7 major areas where the engineers would be required for the design, development, validation of the electric vehicles. And trust me, working in this industry, already the likes of BMWs, Mercedes, they have already started their vehicle program for 2024 from say year 2019, because if they have to launch an electric vehicle in 2024, they really have to plan, and they have to start their programs from 5 years before. So electric vehicles is not a mere hype that we are hearing in newspapers and media, but the things are actually up and running on the ground, and it's a very good opportunity for all sort of engineers, because trust me, the pay scale is very good for people working in electrical engineering domain for electric vehicles. So yeah. Sorry, some issue with changing the slide. So sometimes I have to just take a pause. Yeah, and if I talk of this electric vehicles or any manufacturing or any energy utility company, this product development is a very important thing. PDM is something I think we miss teaching students in a typical engineering course, but it's very important because car is nothing but a product, and to develop that product, this product development management is very important. Without proper product development management, the product would not be up to the customer's expectations, and the company invests a lot of money in product development management. And these are the some of the I'll say topics which comes under product develop management, which is specification and requirement definition. I mean, what would be the specifications of my car, what would be the functionalities, which features I want to put in my car, or any product for that matter. So that comes under the requirement definition. Architecture. So architecture, we have both hardware and software part. So in architecture, it is more about how many electronic control units would be there in my car, what would be the design of my car, what sort of batteries I need to put in my car, what would be the specifications of that battery. So this architecture is very important. It would be a four-wheel drive or a two-wheel drive, hybrid car or pure electric car, diesel car or petrol car. All this comes under the architecture part of it. Software is nothing but what sort of human machine interface would be there, my instrument cluster, my infotainment system, my speakers. So how I'm going to, what would be the features, software features of my car, that comes under the software architecture. Then build and test. So build and test is basically you design and develop those features, and you do extensive testing as per the ISO and other standards, as told by the automotive body of any specific country. Then testing and validation. Testing and validation is like whatever bugs, or whatever bugs you have found during your testing period, you just validate whether these are not of repeating nature, these are not coming again, so that when you sell this product in the market, there is no recall. Because in automotive industry, you can see lot of recall is happening, and that's a big loss to the companies. Recently, I think Honda cars, they recalled some of the Honda cities because of the faulty fuel pumps. So trust me, if this validation and testing is not done properly, there's a lot of commercial implications for companies. So yeah, so testing validation is a very important phase of product development management. And then yeah, field integration and validation, vehicle integration and validation. So wherein you integrate all these hardware and software into cars, and you do testing on vehicle, because the testing that you do in lab is very different than what you do on vehicle. So on vehicle testing is a very important part. And last but not least, field data collection and analysis. So the lot of data is being collected nowadays from the field. The data is analyzed, and useful insights is given to the end user, so that he can use that data for predictive maintenance, for analyzing the driver behavior. And these things are very important for diagnostics and other purposes. So these are the different phases, I would say, of product development. And so this is what companies do when they before they launch a product into the market. This is the different stages. So Then another important field, very lot of opportunities in IT domain in this field is. So this is now specifically to IT domain. I'll say yes, it is applicable to industrial and manufacturing domain, but IT domain, you see a lot of opportunities coming in big data analytics and machine learning. So big data analytics is like there is a manufacturing company like I when during my days in Amul. Amul. I mean, I was working as an external consultant to Amul Dairy in Gujarat, wherein we were responsible to tell them that how to improve the processes in a dairy, right from the packaging processes. The packaging, this Amul milk is getting packaged. That entire process we studied. Then the cooling systems, all these chillers who are responsible for storing these different dairy products. So those chilling systems we studied. Not only that, we were also studied the cattle feed plant. I mean, there is a big plant in Amul wherein they are producing this cattle feed, the food that is given to cows, and they have a laboratory setup wherein they analyze the mood of the cow when a certain combination of food is given to cow. So if the cow's mood is very good after eating that food, the cow ends up giving more milk. So they are also doing that kind of research, that what should be my food mix during different seasons, so that the cow is in good mood and is able to give good amount of milk. So that is the level of sophistication is there in Amul. So
That's very interesting.
yeah, yeah.
Very interesting, I must say.
So yeah, so this is nothing but all these processes we studied, and even a chiller is basic component like chiller in a dairy industry. A lot of data is generated. I mean, what is the temperature, what is the wind speed, what is the energy consumption. So all this data is analyzed day in day out for a month or so, and then there are certain process changes that we recommend to the dairy industry. And trust me, even a 1 degree. Now, what we have found, I'll tell you a very interesting case study. For storing milk, to ensure that it is stored and it is not getting spoiled, -5 degrees is recommended. Example I'm giving, -5 degrees is recommended. So what Amul dairy plant people used to do, they used to keep it at -7. So we asked them that the recommendation is -5, but you are keeping at -7. So they said that, sir, we have to keep some buffer, because we are storing tons of milk and milk powder, and it should not get spoiled. So if the recommendation is -5, we don't want to take any risk. So we are keeping it at -7. So okay, we said okay, fine. But trust me, even at -5, when the recommendation is given, the actual recommendation is of -4. But adding buffer there said that okay, you keep at -5. So buffer is already incorporated when -5 is recommended to dairy industry. Still, they are adding buffer of another 2 degrees Celsius. Then what interesting analysis we did was, because of this additional -2 degrees Celsius, trust me, they were losing. Amul Dairy on a entire in their operations, they were losing minimum 75 lakhs rupees per day, because more energy is required to keep for keep maintaining those temperature ranges. So imagine 75 lakhs per day of money loss, because these people were following wrong processes. And you just multiply 75 into 30 for a month, and then into 12 for a year. So long story cut short, Amul Dairy was wasting crores of rupees, because they were not operating their chiller plant properly. Simple. So then we told them that if you want to keep a buffer, you keep it as 1 degrees, -6, -7 is not required, because -5 is already is taken into consideration the buffer of 1 degree Celsius. So then they shifted their they maintained their cooling from -7 to -6 now, and because of 1 degree, change, they were able to save crores of rupees in their operations. So this is the power of predictive data analysis. This is the power of IoT. This is the power of consulting. And this is the power of streamlining and understanding the processes. So I hope with this example I was able to tell and communicate why the this predictive data analysis is important. It really saves lakhs of crores of rupees for the organization if implemented in a correct way. And then there are tools which are available in the market. And yeah, so this is one of the case studies that I would have liked to elaborate further, but in the interest of time, I'll move on. Then in big, I'll just give a high level process flow that how these big data analytics platform they actually work. So whether it is any industrial application, healthcare application, automotive, a lot of data is collected by the sensors, and there are these gateways which collect that data and push that data into the servers. Or so we have Amazon Web Services, Microsoft Azure, Google Cloud. So all this data coming from different verticals, it is collected by sensors and pushed to the cloud platforms. When the data is into the cloud platform, then there are certain data analytics softwares which are available, which would run simulations over this data, understand the data patterns, and store and make some sense out of their data. So these are all data analytics platform which do this analysis. You can see this thing, exploratory analysis.
So
So
you can take it to the presentation mode. It will be.
yeah, sure.
Yeah, that's right. Yes.
Yeah. So you can see this exploratory analysis is done by the machine learning platform, and then this data visualization. So in this data visualization application, you will actually see dashboards and reports, and reading those dashboards, interpreting those reports, you will understand how I need to implement the data which was collected by the different data analytics sensors, and the whatever the process is done by the the platform. So this data visualization application is the end user application which comes on the HMI, which is human machine interface. It can be on tablet, it can be on mobile phone, it can be on some centralized dashboard in the office of some decision making authority. And then this data is visualized and corrective action is taken in the particular process. So this is the high level flow of data analytics, how it is done in various industries. And now, this smart application, it is not only smart industry, smart cars, even our homes have becoming smart. Now we have smart fire alarm systems, we have mobile applications, we have, even, like now we have Alexa at home. If we train Alexa, so when I enter my room, and if I have trained Alexa knows what is my thermal comfort. Alexa knows that when I enter the room, Alexa recognizes me by my voice. Alexa knows that my comfort factor for thermal application is 24 degrees Celsius. Alexa is very well integrated with my AC application, and Alexa automatically sets the temperature at 24 degrees Celsius. So this is what today's technology have become very smart nowadays, and this is all nothing machine learning, but artificial intelligence. So yeah, and so the whole context, what I'm trying to tell is each and everything is becoming smart, whether it is your home, whether it is your industry, whether it is your car. And these digital technologies is driving the future of our generation. And we should be very much accustomed, and we should be very well know the use cases. If you are able to do that, I think there are ample opportunities for engineers in digital space. Yeah. So I will now move to the next part. So, so I'll just give a quick overview of what we have covered till now. we covered what are the engineering opportunities for the next decade or so, from the whatever insights I was able to gather from the industry that I have worked with. Then then we talked about the major technology trends that are in the automotive sector. Then we talked about the electric vehicles. We did a deep dive into what is mean by product development management. Then subsequently, I talked about the big data analytics and machine learning. I gave the use case of chiller application in Amul Dairy plant. Then we touched upon the data analytics platform, right from how the data is collected to how the dashboards are used to interpret the data and take corrective action. We talked about the smartphone applications, that how with the technologies like Alexa and all, our homes are becoming smart. So if anyone have any queries, I'll be more than happy to answer this.
So all the attendees are requested. You can unmute yourself, and in case if you have any queries, you can directly talk to the resource person. If you are not comfortable to unmute yourself, what you can do is you can write your query in the chat box, and we can read it out. So if you have any queries, please go ahead.
Okay, so I feel lucky that my life is becoming easy. I'm not getting any questions. So yeah.
That's a good way of putting it, sir.
Okay, so I'll move on to the two-wheeler engineering. See, I'm just not saying that that IT field is not something that should be the area of focus. All I'm trying to showcase here is that beyond IT, there is so much engineering services opportunities that are there, and somehow during our engineering we miss that what opportunities are there beyond IT, because it's a trend. TCS comes hire 300 engineers, Accenture comes hire 200 engineers for IT, Tech Mahindra comes hire 150 engineers. So for today's engineers, the end result have become to work in some IT company. And even now the likes of White Hat Junior, they are promoting that you should teach coding to your kids at the at sixth class and all. Of course, the discussion is not going into that direction wherein I am debating whether it is good or bad. The only point that I want to make is that there is whole lot of world that is there in India beyond IT. So with that background, I will start with two-wheeler engineering. So yeah, I mean, two-wheeler, we are India is a two-wheeler loving country. Even in COVID-19 situation, post-pandemic, the two-wheeler sales was somewhere around 90% of the pre-COVID times. So Indians love two-wheelers. There is no doubt about it. Statistics are there to support this statement. So in two-wheelers, there's a lot of engineering that goes, in making a two-wheeler, and there's a lot of ample opportunities now that two-wheeler is also shifting to the electrical way, like infotainment and cluster, your this speedometers and all. So it's going ahead. You will not see only a speedometer or a petrol level indicator on your vehicle. There would be a lot of things that you will see, like the likes of Google Maps, the kind of Alexa, support on your on your vehicle. So expect that features to come in upcoming vehicle that would be launched in India post say 2 years, around 2022. So in infotainment and cluster, there is a lot of requirement for design and development, app development, HMI development, smartphone integration, middleware development, verification and validation. So all these typical computer science and IT engineers, they have a good scope in vehicle engineering. Then electronic mirror. So electronic mirror is every time I sit on my vehicle and I adjust my mirrors as per my comfort level. But now there are memory based electric mirrors. So when I start a vehicle, the my tooler is intelligent enough to understand, which angle I'm, comfortable with my mirror. So, even if someone has fiddled with my mirror position, but when I switch up my vehicle and press a button for mirror, the mirrors are smart enough that they reposition themselves to my, to my view of comfort. So these are, smart electronics mirrors that are coming in vehicle domain. Then lighting, like adaptive front lighting. So what is adaptive front lighting? When I'm going in dark, I switch on, means when I'm going in a dark area, I switch on the upper dipper system is there in our two vehicles. But now the vehicles which are coming, they have smart lighting. So as per the ambient lighting, the lighting switches power automatically. You no need to rely on that upper dipper switch while driving a vehicle. So if you're driving a vehicle in the daytime and suddenly say around 6:30 p.m. the darkness have come around, so you need not to worry about that. Your vehicle is smart enough that it will start a bright light on its own. It will adjust the brightness to your comfort of riding. So that's how smart lighting systems are being now implemented in vehicles. Battery management systems, of course, battery management systems are going to be the heart of any electric vehicles that are coming in the market. So battery management systems, then engine management systems. So yeah, so here the all electrical and mechanical engineers would have a lot of opportunities in the upcoming years. Then emissions. So now you must be knowing that in India all the two-wheelers and four-wheelers are migrating from BS4 to BS6. So what is different in BS6? So in BS6, there are certain particulate matters that needs to be filtered. No more is the case that these particular matters, these particulate matters would be allowed to emit directly into the air by vehicles. No, that's not the case. You have to filter those. You have to put those systems into the vehicle so that the emissions are adhering to the pollution standards and the local environmental laws. So yeah, so here a lot of those I'll say sustainability aspects comes into the picture, and subject matter experts in energy environment domain, they have a lot of requirements and demand in the industry. And then advanced driver assistance. So in two-wheelers also those systems would come into the picture, that sensors would be fitted into the front of the vehicle, and if those sensors are sensing that you are going to collide with the vehicle in front of you, then automatically the braking systems would be initiated by the two-wheeler. So it will help in avoiding the accidents. So this is how the high-tech vehicles are going to become in the coming future. And trust me, it's not going to be a reality in 2030. In coming 2-3 years, all these things would be a reality. Already in European market, some of these features are already there in their vehicles, and I have absolutely no doubt that India would adopt these features at the earliest. So yeah, there's some problem with my system that it cannot automatically go to the next slide. So every time I have to escape, go to the next slide, and again go to a full view.
That's absolutely fine, sir. No issues.
Yeah, yeah. So in automotive engineering, these are the, I'll say, 6 major areas where we see a lot of demand for engineering students. That is embedded software, like control software development. Then AUTOSAR is a body which defines the, automobile software, how the base platform should be, what should be the features and specifications of the, automobile software. So yeah, so AUTOSAR related consulting, then software testing. So these are the interesting areas where there are opportunities. Then I'll say hardware, like the hardware that goes, the electronics hardware that goes into the vehicles, the thermal analysis, the vehicle harness design. Vehicle harness design is nothing but the wiring harness, the electrical systems that are fitted into the vehicles, then the testing. So these are the areas where there is a lot of requirement. Then of course HMI, as I said, that even don't be surprised that your HMI is now Android based in the upcoming years. TV have become Android, mobile have become Android, your car systems have become Android, and it's just a matter of time when your two wheelers would also be Android based. So yeah, so HMI design, that is human machine interface design development, your so all those testings in the and validation in the software that comes under HMI. And of course the validation means on vehicle testing, you validate that whatever features you have developed are working as per the expectations, there are no bugs in those. And then FUSA is nothing but functional safety, FU for functional, SA for safety. So there are ISO standards which are defined. Your vehicle should be compliant with functional safety, and without functional safety, you cannot launch your vehicle in any market. So that functional safety is another important aspect. You see, in this advertisement, they say that XYZ car is safest in India. It got 4.5 rating out of 5. So all those things are nothing but the part of this functional safety domain. So there also a lot of engineers are required for consultations, re-engineering, hazard identification, and safety assessments and audits. So these are the opportunities that are there for engineering students in the automotive engineering space. Yeah, lighting, as I've already told you the use case of adaptive front light system. So even in lighting systems, there is a lot of engineering that is involved, like from schematics capture. Schematics capture is nothing but design. Every new vehicle which is launched into the market is known by how it looks, what is the design of the headlamps, or generally you see when a new version of a vehicle comes, overall most of it is the lighting systems, you will see that that have been upgraded. So yeah, lighting engineering is very important and interesting topic, and there is a lot of opportunities. Generation of bomb. So see, again, I'll tell you what is bomb. Bomb is bill of material. So typically I was working with one of my with lighting companies, and they wanted to implement this adaptive front lighting system in their vehicle, and we gave them very good solution. But they told me that, Rohan, to implement this solution, the material that would be required to implement is costing me around how much? 8,000 rupees. So typical a two-wheeler where I'm trying to implement this solution is costing 80,000 in the market, and the solution that you have given is costing 8,000 rupees. So imagine the lighting cost of my vehicle is somewhere 10%. So he's saying that just because my lighting is up to date, people is not ready to shell out extra 8,000 rupees. So you please optimize your bill of material. I want the same features, but my target for BOM is only 5,000 rupees. So you understand, no, the business case here, right? I am giving or developing some system for my end customer. The features are great, but the costing is high, and customer wants me to reduce the cost by 40%. So he wants the same features to be done with materials which are cheaper by 40% than what my engineering team have developed. So then it involves a lot of innovation. Frugal innovation in India we call Jugad. So yeah, we did a lot of frugal innovation, and we were able to come down to the BOM pricing of 5,000 rupees. So these nitty-gritties, I'm pretty sure today's education system, because of its limitations, is not able to tell these things to students. And I think if students are working closely in the industry domain, they would understand these aspects which are very important in any product development. Then of course, software design, software implementation, testing of prototype boards. So these are the other areas in lighting engineering. And trust me, all these automotive companies which are in Europe and US, they have a lot of demand for lighting engineers. In my own company, there are people who have extensively traveled to US and been there for 5 years, working on the lighting engineering program for the likes of General Motors and other companies based out of US. So yeah. So this is high level systems and software engineering requirements, or I'll say when I talk of system and software engineering in vehicle, there are a lot of subsystems into it. So I don't want to deep dive; it would be too much technical. But this vehicle operational level, vehicle requirements, functional engineering, subsystem requirements, what should be my software architecture, what should be the testing of components for my software, then the functional integration, and of course the vehicle testing. So these are the different things that goes into while designing any vehicle. So yeah, so these are the high level overview of what is systems and software engineering for automotive domain. Since I want to keep it as a very industry related discussion, I don't want to make it very theoretical. That's the whole reason I will not do any deep dive into it. And if someone have very specific questions to these slides, you can feel free to get in touch with me post this session or maybe at the end of the session. Yeah, testing services. So testing services. So I'll tell you, the only the seating systems in car, that also goes through a lot of testing. Trust me, it's no more a case that a car company orders a seat from some of the tier one company and that is fitted into the car. No, before it goes into a car, a lot of testing happens even for seating systems in lab. You can appreciate the kind of testing setup that is there. This is very high level, sophisticated, lot of investment goes into this testing setup. So this is a very typical testing setup for testing the seating systems. So, and trust me, all these testing engineers, they are they earn a good amount of money, and it is very interesting. What kind of vibrations, what kind of noise, whether if there is any accident, whether this seats would ensure the safety of the passenger. Everything is simulated, tested in the lab environment, and then only the seats are allowed to go into the car. So yeah, and then there is a lot of software based simulations that is done because testing in various actual scenarios means a lot of investments. It also means a lot of time that goes into it. So people have made it software based testing, wherein the software is able to simulate various environments and is able to test the strength of the seats. So yeah. Then again, as I said you that one of the topics that I want to touch upon is design engineering. Design engineering is whatever you see on this your instrument cluster of car, or you see your driver is there. He's interacting with the infotainment system of a car, information system on the car. So there is a lot of design engineering that goes before such panels are fitted into the car. The if I had to list down those, this would be the specific documents for complete feature list. So what kind of icons, what kind of features, whether it would be Android based or Linux based, then what would be my different icons, what would be the color of those icons, how I want the flow of icons. Everything is designed by a this design engineer, and it is documented before it is approved by the design head, and post that only it goes into the car. So trust me, infotainment system in a car or a vehicle is something which brings the wow factor to the car. That is the whole reason there is a lot of engineering that is involved into that. Then then test strategy definition, what kind of testing should go before this unit is fitted into the car. Because tomorrow I don't want that I want a GPS function in my vehicle. Instead of GPS, it have opened up some other app. So those glitches are not acceptable, because whatever goes into the car should be fully tested to to ensure that there are no glitches. So those trace strategy definition is there. Then then there are definitely the integration with different systems. So for example, if my vehicle, I have fitted a system into that it gives an alarm if my vehicle is exceeding the speed of 100 kilometers per hour. So my instrument cluster and my infotainment system should have an integration. So my infotainment system should able to collect data from my speedometer, and once the speed is above 100 kilometers, it should give flash some icon in that display, so that driver is aware that he has breached 100 kilometers per hour mark. So all those integration needs to be done within the subsystems of the car. Then supplier coordination, even in this infotainment system, the panel is given by one of the customer, the speaker is given by one of the customers, the buttons and the control sets is given by one of the customers. So a lot of supplier coordination and is required, and that is how the design engineer is should be capable to do a very seamless supplier integration. um, then and then there are test labs, diagnostics software, other features development. Then not only that, a lot of over the air updates are being sent to this display system. So the software is getting updated every year, because the same software cannot run on this car, because every year customer wants some new interfaces, like your Android gets updated every year, your iOS gets updated every year. So this software also needs an upgrades. So all those upgradation, how it will happen, so that connectivity also needs to be given to this. Nowadays you will see that SIM card is integrated in this infotainment systems in cars like MG Hector and all. They have branded their cars as connectivity cars. So in this way, there are good opportunities in design engineering as well, and I think people should explore those if they want to do something different than just end up in typical work profiles that every other engineer we see in today's setup. And again, I mean, as I said, there is lot of there is lot of requirement for human machine interface and UX, that is user experience engineering. So it involves mainly design and development. So in design you have research and benchmarking. There is a intense competition in this space. How my design should be differentiated is very important. If Honda is using the same design as in Maruti, then there is no differentiator or USP for Honda to sell their vehicles in the market. So this research and benchmarking is very important, that how my product is different. Then requirement specification, what my end customer wants, what are the features he is aspiring in the vehicle. Those requirement specifications are very important during the design phase. Then interaction design, how my user would interact with the HMI, whether it would be through buttons or whether it should be through touchscreen. Nowadays it is on another level. Nowadays the interaction design is more voice based. You understand, voice based. Everyone gives commands over a voice, and they expect that the HMI should respond to those commands. What should be the visual design, and basis that what should be the concept development. So what should be the content in my HMIs. So these are very important. Now Kia Seltos have come up with a new vehicle, Seltos. So why it is selling? Because their infotainment system have a heads-up display. So you can see the speed. You can you can see what music I am hearing on a display, heads-up display, not only on my HMI. So they are coming up with such innovations. That's why their products are different and they are selling. In development, it would be like HMI framework. HMI framework means what kind of software I want to go with, what should be the architecture of my HMI and the user experience, business logic development. So from the business perspective, if I have a target that my system should not cost more than 20,000 rupees, then how I'm able to do that? That comes under the business logic development. Simulation is nothing but testing those systems. Porting and optimization. Porting and optimization is when you develop these things into a lab or on a computer, but you port that into an actual HMI on the car and you test it. So these are the design and development opportunities in HMI and US engineering. And trust me, the likes of Harman, the likes of JBL, the likes of Samsung, the likes of LG, the likes of Bose. I think yeah. So these companies are hiring a lot people in HMI UX engineering, and yeah, this is a very good domain uh, for people to work. And if they have the right skill set, they would be more. They would be paid at least, I'll say, 50% more than typical. What is being paid by the IT companies like TCS and Wipros. Yeah. So this was, a typical. I'll just go into what we have covered till now. We just covered what goes into a two-wheeler engineering. Then we touched upon the wider area of automotive engineering. What are the opportunities and what exactly, when we talk of automotive engineering, what does it really means that we understood in these slides. Then we touched upon lighting engineering, wherein I specifically talked about the BOM concept, that is bill of material concept. Then we talked about the testing services for setting systems. When we understood the opportunities in design engineering and what actually goes into a design engineering. Then we talked about the HMI and the UX engineering, the opportunities and the things that are covered under design and development. So with that, we have reached, I'll say, interval of our presentation. So yeah, so if someone have any questions, I would be more than happy to address those. And I'll request just 2 minutes. I'll just switch on the lights. Uh, so just request 2 minutes.
Sure, take your time, sir.
Yeah. So if anyone have any questions, I'll be more than happy to address.
If any of the participants or any of the attendees, if you wish to ask any questions, you can always unmute yourself and question the expert speaker directly. Sir, I do have a query in this zone. You see, you mentioned that this is an upcoming branch of, this is a profile which will be highly in demand in the time to come. And there
Correct.
is no doubt about it when we discuss it as well, because the way we see things progressing. However, the question is, why do you think there is, why do you think that in engineering curriculum, or not just in curriculum, but otherwise also, why do you think there are no, like what happens usually is, even if the universities, they do not adopt this in their curriculum, then there are online, there are these e-learning classes, or there are some other private classes, private coachings, wherein such things are adopted. But are there any such classes, any such coachings which the students can join in, wherein they can develop expertise, or which will help them get into this sector? That is question number one. And question number two would be, if there aren't any such, if there aren't any such things available, then what is the alternative that you would suggest as to what is it that the students can do to ensure that they can train themselves well while they are pursuing engineering in this sector?
Yeah, yeah, definitely. I mean, I completely agree with you that there is lack of awareness among the people as to from where this knowledge can be acquired. So the answer to this question would be that now with the likes of companies, education companies like Coursera is there. Then I'll say An Academy is there. So wherein this UX, UI, UX design is very these topics are available there, and you know, uh, and even good engineering colleges like I Square IT Bangalore, that is Indian Institute of Information Technology Bangalore. They're offering the courses in data analytics and UI UX engineering. Then yeah, so I'll say with greater adoption of IT in engineering field. Uh, these courses are no more available only in certain sections of the colleges. It is now very well available, and if students make use of these portals or these platforms, rather, they would be able to get theoretical training for sure in this domain. So they should explore these platforms. Definitely they would be able to get good insights about these courses in these platforms. And another alternative would be that during this, I'll say winter or summer internships, if they actually work in industry, any industry, whether it is energy utilities, manufacturing, automotive, if they're willing to go and visit these industries and do internship, no, they will actually understand it more clearly from the practical aspects. So both things they should do. They should give good, preference to on-the-job training by doing internships in such organizations, deploying such technologies. And second thing is they should learn these things from online platforms. So, and now knowledge is available with the upcoming technologies. The knowledge is available. Yeah. So this would be my answer. And trust me, even if that hunger is there in students learning, no, even industry people are more than happy to take students on internships. If that really people are interested to know these technologies, there are companies who are happy to have such curious minded and technology oriented engineers as interns. So there is no limit as far as you have a drive to understand these technologies. There is nothing stopping you from gaining the relevant knowledge. Yeah.
Thank you, sir. That answers my query.
Yeah. Now, since my inclination is to make this session little, I'll say, practical oriented, to discuss about the things on ground, I would like to now talk about certain case studies that I have come across in my career, and would like to tell that how these different technologies we were able to implement, in reality. So this is a very interesting case studies that I have done in one of the companies who were manufacturing these baggage handling systems. This work I have done during my PwC days. I was working in PricewaterhouseCoopers as consultant for process optimization, and we have got this requirement from a bag handling system manufacturer, that due to the failure of baggage systems into airports, we are getting a lot of complaints from our end customers, which are the airport authorities who are our customers. So you please come, study our process, and suggest us a solution. So the as is process was that this was the as is process. So what was the pain area of the customer? That if a belt has malfunctioned, it took some time to understand that which belt have malfunctioned, and then to for that service personnel to inform the maintenance team that okay, the X belt on say one line have malfunctioned. Then uh, then the on-field ground staff would figure out the alternate belt because that belt is not working now. That would result in delayed schedules. The end customer would not get their bags on time, and if customer is not getting bag on time, they would create halabula in the entire airport. So so for a belt handling system company, giving bag on time to the end customer is a very critical thing. Then not only that, it would lead to rapid baggage buildup if the system have stuck somewhere. So the result is I have an unhappy passenger, which is not good. So what we did was we tried to study the entire system, the IoT, and tried to see if we can implement IoT in that overall system. So then we put the IoT sensors in the entire system, which can integrate, which were integrated with the IT systems. And of course, there was a gateway which would send the data to the cloud, and from cloud the data would come to the mobile application, and we would know the parameters like the name, the belt, where it is located, the status, whether it is running or idle. If a belt has malfunctioned, the sensor would send the alert notification to the different stakeholders, which is the maintenance staff in this case. Then the maintenance staff would get the exact details of which belt have malfunctioned, and they would take immediate corrective action. So the end result, what it will have no zero schedule impact. It will not lead to any zero pileup, because the time the belt have malfunctioned, the people are able to take corrective actions on ground, and which will lead to great passenger experience. So in this way, we were able to give a great passenger experience by enabling the IoT into the baggage handling system, and the end customers reduced, and the baggage handling system company was very happy, and and then we got more orders from this company. So this is what is consulting. This is what you solve the end customer's problem by actually implementing the systems on ground. So I hope you were able to get the flavor of the power of IoT applications in the day-to-day applications. So this was the use case of predictive maintenance with IoT. So in the backend, what actually happens is that before a belt malfunctions, the system is able to understand that with the parameters, maybe if a belt have bearings have reached a certain temperature, they understand that when the temperature is say beyond 80 degrees Celsius, there are high chances that this belt will malfunction in another operation of say 80 hours or 90 hours. So that intelligence is there because of the IoT. So they know the health pattern of the belt, whether it is good health or poor health, by monitoring the different parameters, and they the unusual patterns are is already detected by the system, and the corrective action is already in place. When they know that in the next 80 hours this belt is going to malfunction, they have already started working on that beforehand. That is the outcome of this implementation. The maintenance staff gets the alert, and and then they manage to solve the problem before it percolates into the system. So it helps in preventive and proactive maintenance. It helps in process optimization. Of course, process optimization will lead to cost optimization, and the end result would be a great passenger experience. So that was the case study for belt handling system. Then electric pad detection. So this is another project that I have done. One of the pain areas for electric vehicle is that during the charging time, if my charging time about 70-80 minutes, a driver will feel that he is wasting his time till the time battery is getting charged. So what we have done is a IoT implementation of the charging pad, wherein when there is a seamless integration of charging status with the mobile. So a vehicle goes in the charging station, uh, and that charging station alignment we can see on the mobile app. So I know where I have to park my vehicle, so that my vehicle is getting charged, and the active status of my battery charging is live on my mobile. So till the time the battery is charging, I can go to nearby mall or a food station, or I can go to some work and do it. Not it is really required that I need to stay near my car till the time the battery is getting charged. No, wirelessly I'm getting those signals on my vehicle, and because of which I can utilize my time better. And also for alignment of my car over a charging pad, all that assistance is given through mobile application. So this was the another use case for electric pad detection. I actually told you the very details of that application that might not have been told in the scope. but the scope overall talks about the alignment assistance with the integration of the camera with the mobile. Yeah. Now, this is also another important case study that I wanted to talk about. So, this is regarding, this was regarding a car manufacturing company, wherein, we were helping them for a, reduced downtime. Because of the machine failure, the car company was facing a lot of downtime. And you imagine, when in a car industry there is a downtime, they would not be able to meet their production target. So suppose their production target is that they have to manufacture 10 cars per day. So if they are not able to manufacture 10 cars per day, then the vehicle wait time for the end customer would be more. And then if someone, and it is very important, if if I go to Tata Motors and they tell me that the wait time for a vehicle is 3 months, it might influence my buying decision if I want my car immediately. So imagine a low downtime in a manufacturing industry would lead to buying decision, would affect the buying decision of the end customer. So in car industry, they cannot afford a downtime in the in the manufacturing process. So what we did was that we went to the this car manufacturer, and we analyzed different data. We collected different data through sensors, and what we have found out that our data collection and analysis would take at least couple of weeks. So if a machine have malfunctioned on 7th day, to repair that machine will take another 14 days, because we have to go collect all the data, then understand what is the problem, then take corrective action into that. And automotive industry would not have that time, you know so they asked us that, can you implement some IoT based solution or some high technology solution. So then, we implemented a artificial intelligence based solution, wherein it was a AI engine based platform, wherein the continuous data was monitored by AI engine. And the AI engine is so powerful that it was able to analyze, that something will go wrong beforehand, because of that AI engine. The AI engine was so strong that it had the capabilities to detect the anomaly beforehand. So it would tell the end user that in the next 100 hours of your machine, it will break down because certain components, the vibration is more. And our intelligence tells us that when the vibration is going beyond a certain dB range, there is a high probability that machine will fail. So during the non-manufacturing hours, the support staff was able to replace the parts, and there was virtual zero downtime in the machine, and the customer was able to meet their manufacturing target of say 10 cars per day without any stop in the process. So this is the power of IoT. This is the power of artificial intelligence, and I'm pretty sure that such use cases won't have been it's not possible to share in classroom environment, because due to the lack of industry institution understanding, the students are not able to understand the things on ground. And I think this case study is a good example as to why students should work on ground after every semester. Even if it's for 15 days, that's fine, but they would be able to appreciate the power of artificial intelligence and the other powerful next generation technologies that is being spoken of in today's world. So what we did was making the power of artificial intelligence available. And so timely action uh, really helped the customer to reduce the machine downtime. So this was the overall case studies. The similar case study, we did for one of the application in a pump industry. So pump, the motor drives the pumps. So
Rohan,
any, yeah,
sorry to interrupt.
yeah,
Yeah, this is Sunil, sir, the co-coordinator of this faculty development program. Actually, I want to
yeah,
ask one question based
yeah, sure,
upon artificial intelligence and machine learning. Sir, can you
yeah.
just tell us what are the popular organizations that are providing the training based upon the industrial projects, so that they can train the particular students? Can you just tell us some of the organization or some of the institutes that will be help us for our student for doing the industrial based project training in that particular institute?
Yeah, yeah, yeah. The likes of CDAC is there, the likes of I Square IT is there, and so these are two prominent, I'll say institutions are there which are providing training in AI and ML, that is machine learning domain. So yeah, I Square IT and CDAC. And
Okay.
even you go to these platforms, as I've mentioned earlier, on Academy and all that. So they have tie-ups with the foreign and India-based universities to for courses in this domain. So those are also good platforms. But if you personally ask me, then CDAC and Ask Your IT is something I would recommend to students. And these are good 1 year programs, 6 months program, 3 months program. So as per the convenience of the students, they can do these courses. And trust me, these are very useful programs. Around 10 years back, this PLC, SCADA, these programs were very relevant to the industry. But I would say now PLC SCADA are relevant, but if you add the flavor of AI and ML to the PLC and SCADA, then trust me, sky is the limit for the students to excel in these domains. Yeah,
Sir, one question is also there.
yeah,
And like just the computer science students or the electronic students, they are more available about this particular artificial intelligence and machine learning. But my
yeah.
question is that if the students are from the electrical engineers or the mechanical engineers, can they do this particular courses?
Definitely, I mean these courses, these AI and ML, they are applicable to all these, not only IT and computer science. In fact, AI and ML is more relevant for mechanical and electrical engineers because I'll tell you,
Okay.
all these machineries in manufacturing, automobile, and energy utilities domain and oil and gas industries, these are all electromechanical machines. So, electrical and mechanical engineer is much more in a better position to understand the functioning of these machines. And since they know the domain, they can actually apply AI ML in a much better way. So I'll say it's other way around. Electrical and mechanical engineers are much equipped to implement these technologies on ground level. Yeah,
What
and
happened?
uh, and to develop these engines, these AI and ML, the IT and CSE engineers are more capable. So see, understand, to develop this software which drives the AI and ML, IT and computer science people are well equipped. But to implement these technologies on ground, electrical and chemical and mechanical engineers are more equipped. So that is the difference between the two. Yeah.
Embedded system that hardware and software both are required in this domain, that artificial intelligence. No.
Yeah.
Thank you so much, sir.
Yeah. Thank you. Thank you, and that was a very relevant, discussions, and I'm happy to, have such discussions in, in whatever time that is remaining. Yeah. So I'd like to give an example. So I'll tell you another example, on-ground example, because I'm very interested to share the on-ground learnings that I've gained. So actually, I was working in this for Rajasthan Water Supply Corporation, and this Rajasthan Water Corporation was supplying water to different villages. Now, see, water distribution is very critical in Rajasthan because you know the situation in Rajasthan. The water is not available 24/7, and whatever time the water is available, people, are like just waiting when water is coming. So, water distribution is a very critical application. And what was happening is, since these pump sets and motor sets were installed 20 years back, these were very old pump sets. So there was a lot of failure in these pump sets, and people were not getting water, every day. because of the failure of the pump sets. So what actually happened is that all these people went to this Gram Panchayat collector office and they started pelting stones. And he had a very hard time to convince them that I'm not getting approval to install new pump sets because that would require a lot of investment and the government is not having funds, and there were other reasons because of which they were not able to replace the old pump set with the new pump sets. So then these Rajasthan government people, they approached PwC. They told that if you are able to give some solution, some consulting as to how to reduce the downtime of the pumps, that would be really helpful. Because if new pump sets are say costing 100 crores, we don't have budget of 100 crores. We only have 20-30 crores with us. So it makes sense for us to come to you, give you 5 crores to tell us, what process optimization is required in pump sets, and maybe spend another 25 crores in repairing, overhauling, and process optimization of the pump sets. So it makes sense for us to overhaul and optimize the system with the budget we have, rather than completely, changing the pumps. So that was a task, going to these villages, understanding these pumps which are like 20 years old. So then I went to these villages. Trust me, these were like 100 kilometers away from Ajmer. And there are a lot of snakes in these pumping stations. So in those hazardous conditions, I have to analyze the data and implement the sensors in these pump sets. And even we will not get even a pack of Parle-G in those areas because they were so remote, 100 kilometers from Ajmer. So imagine the remote areas, we need to go, and just giving a background of the difficulties which we are faced while implementing this project. So see why I'm telling you this thing, because every time it is not possible for us to go to that pumping station, analyze the problems in the machines, come out with a solution, take a and then take corrective action. So we needed a solution wherein we can remotely monitor the status of the pump sets and the motor sets. So that was the solution we were seeking, and IoT was a very apt solution for that. So I went along with the my team. We implemented sensors on the motors, and these sensors were precisely monitoring the voltage, the RPM, the current, the armature temperature, the vibrations, and this sound detection and monitoring. Because when you analyze these parameters, you will immediately know, if you are a very good engineer, if you are monitoring these parameters of voltage, RPM, current, temperature, vibration, and sound, you will be able to understand that the motor is not working properly, and in the next say XYZ hours, this motor is going to fail. So we implemented sensors. All the sensor data was pushed to the cloud, and from cloud, sitting in PwC office in Gurgaon, I was able to get that data. Not only that, that data was given to a AI-based analytics and prediction platform, which was made by Renesas company. And that AI platform would tell us that what is the mean time to fail. So mean time to fail, this MTTF is a very benchmark parameter. So when I have a mean time to fail, I would know that this pump is going to fail in next 80 hours. If it is going to fail in next 80 hours, then immediately I would call the pump operator who is sitting in Ajmer, and I will tell him that, see, the temperature, the vibrations are beyond certain dB. So might be the case in the armature winding, there is something problem is there. So you immediately go to that remote place from Ajmer within say max 2 days, because if my machine is saying that it will fail in 80 hours, means within 4 days I have to take corrective action. So I have to keep some buffer. So I'll tell him that in the next 3 days, the problem should get solved. Otherwise, the villages in will start pelting stones to the Gram Panchayat officer. So if you don't want to do that to happen, you please go and take corrective action. So you understand the context, the power of IoT, the power of AI-based platforms. Sitting in Gurgaon office, I was able to monitor and take corrective action of the pump sets. We were so remotely placed in some of the jungles in Rajasthan region. So this is this is the power, and this is the the end implementation of IoT. So I hope with this case study you would appreciate how important the IoT is there for industrial applications and water supply distribution companies. Yeah, so similar. I mean, similar uh, use cases for gear manufacturing company, wherein we implemented this AI-based platform, which would analyze the data, and whenever there was abnormal vibration, we would understand that something would go wrong in the coming days. So we need to take predictive action. So there is a zero downtime. So we come to the end of this case study session. I'd like to give a brief overview. So we touched upon the use case that we implemented for a baggage handling system maker. How IoT is able to reduce the downtime and give the wow factor to the end customer. Then we talked about how electrical pad detection system with mobile integration is able to help customer to utilize his time when the battery is getting charged, and how the cameras on car are able to help driver to align his car appropriately without any assistance. Then we talked about this anomaly detection in car manufacturing company, that how AI engine is helping. Then assuming that it was a very good case study, then we talked about a very live example of machine monitoring and failure prediction for a pump distribution company based out of Rajasthan. Then we talked about similar applications in gear manufacturing company and other industrial application. So with this, we complete the three out of 4 quarters of this presentation. And again, I would like to open the forum for any technical queries. And post that, we will go to the last section, which talks about the key engineering areas in the upcoming years. So, I'd like to take any questions.
If there are any queries, you can just unmute yourself and talk to the resource person directly.
Okay, if there are no further queries, I would like to start the last session of this entire lecture. So it talks about the key engineering areas. Yeah, so I'll start with the artificial intelligence group. This talks about the area of overall equipment efficiency. So there are a lot of opportunities, like I discussed about the IoT, wherein people can work in AI, robotics, predictive analytics, domain, which would help the end customer to improve the overall equipment efficiency. The good part about this area is that you need not to work for some organization. If you have understood the nitty-gritties of this domain, then as an independent consultant also you can work with different companies. I have a friend of mine who have worked in a consultancy firm, PwC, for 10 years, and now he have started his own consultancy firms. And trust me, he is now the consultant for leading oil and gas industries based in Dubai and Middle East region, wherein he is helping those companies to implement IoT for predictive maintenance of the oil and gas equipment, and he's doing very good. So yeah, so in the capacity of individual consultants also, you can work in this domain. More or less can be talked about the predictive maintenance domain. These are more or less the same area, the equipment efficiency and predictive maintenance. Yes, the another area is connected components. As I told you, that any failure in motor means that the fault will come in pumps, because pump and motor work in sync. So here also they need to be connected to ensure that the fault which is coming in, say, motor, would give a signal to pump that okay, since the fault is about to happen, we need to restrict the functioning of pumps so that the pump is not getting affected because of the spikes in voltage and current. So this connectivity between two devices is important. So this connected components is also one of the important domain which can be pursued by the people who wants to work in this artificial intelligence domain. Cognitive analytics, like in smart city domains, the cameras are becoming smart. If some unruly incident is happening, the smart camera is able to give that indication to the police stations that yes, some violence is happening in XYZ region. You please do some corrective action, otherwise there is a risk that the violence would erupt further. So this is nothing but part of the cognitive analytics. So these are the four areas where people can pursue their career in artificial intelligence. Then another area is automated inspection. So automated inspection is like Amul is producing I'll say so many milk pouches every day. So the process was quite manual. Here again, I would like to give the example of PwC experience. So Amul was actually when they are exporting milk powder to Middle East, entire milk, each and every milk packet, that milk powder packet, they need to inspect. So they have to inspect them manually, wherein the people would use some infrared devices to see if there are any bacteria content in those packets, and if certain parameters that they are measuring are within the acceptable range. And so it was a manual process. So from actual, so it was taking a lot of time for inspection. And due to human error, sometimes even a single error of inspection means that the entire shipment would get rejected. So it happened, one of the engineers by mistake, due to human error, was not able to detect the anomalies in the packet. And when that packet was inspected by the import department in Dubai, the entire shipment was rejected, and it led to crores of losses to Amul. So they understood that they cannot only rely on human eye for inspection. They need some system, automated system on which that would be error proof. So then they installed this automated inspection system, which was driven by AI platform, and AI was used to detect each and every packet. And the good thing was that post implementation of this automated inspection system, not a single consignment was rejected by the Middle East import authorities. So whatever investment they made, because these machines are not cheap, they would come at crores. But you only tell me, if a machine is costing 10 crores, and if not a single shipment not a single shipment was getting rejected, they have gained their return on investment on those machines. Because a single shipment, if it is getting rejected, they run the loss of 20-30 crores. So it makes sense to invest 10 crores and in these automated inspection machines, that than facing a risk of your consignment getting rejected. Then so that was another project that I did with for Amul Dairy when I was working in PwC. Process optimization, again I told you that using AI we have optimized the process in baggage handling system, and the ROI was fantastic. Within 9 months they were able to recover the cost or the investments that they have made into buying these equipments. Then augmented reality application, so I have a very interesting case study here. So now we are working in the rail domain, and in this digital world, one of our customers have backed the orders for producing wagons for Delhi Meerut Metro. This would be inaugurated by Narendra Modi, and what we are creating for them is a augmented reality application, wherein at the time of inauguration, Narendra Modi would wear the 3D glasses, and there would be an iPad in front of him, and through this augmented reality 3D glasses interface, virtually he will get the look and feel that how is the metro, when he enters the metro, how is the sitting arrangement, how is the public address system, what would be the look and feel. So So he need not actually see the metro physically. Sitting in his place in Delhi, he would be able to visualize the experience of the customer using these 3D glasses and the VR AR solution, augmented reality solution on iPad. Because if now everyone is working on digital technologies, so that was the so this company also wanted to try their hand in digital technologies, and yes, we are helping them to create this augmented reality application for the train experience. And we are as an organization, we feel proud that the same would be inaugurated by Narendra Modi. And for another metro project that we are doing, the similar application would be inaugurated by Mr. Yoginath, the Chief Minister of Uttar Pradesh. And so these are the things, and this is going to be the future. I mean, next time you want to buy a car, you need not to go to a showroom and take a test ride. It's, of course, for the riding comfort, you need to have a test ride. But if you want to get a look and feel of the interiors of the car, there is no need to go to a showroom. The salesperson will come to your place. He will give you an iPad. He will give you these headsets, virtual reality headsets, and using that you will be able to experience the look and feel of the interiors, the HMI, the sound systems. All these immersive experience will be able to get at home without actually going to the showroom. So these are some of the applications of the augmented reality. Autonomous guided vehicles. So typically in supply chain industry, the autonomous guided vehicles is the case. Now imagine the likes of Amazon and Flipkarts. They have a huge warehouses, trust me, spanning acres of land. And when they want to optimize their parcel delivery, parcel pickup from X location, delivering to the Y location for packaging, then delivering to the Z location for dispatch. So this entire can be done by autonomous guided vehicles. In fact, the delivery is now done by drones, which are all automated, which is nothing but an autonomous guided vehicle. So it is no more a futuristic thing. This is actual happening in Amazon, wherein through using autonomous guiding vehicles, they are optimizing their supply chains. Not only that, they are using drones and autonomous guided vehicles to deliver the parcel to their end customer. And I think there is tremendous amount of opportunities in these areas. So moving on to the next part, yeah, data visualization. As I told you, the reporting and making sense of the data that has been collected by the sensors is going to be. It is a big thing in industries. There are companies who are multi-million dollars companies only working on the data visualization and analytics. Then a plant performance analytics, wherein a person, a quality head sitting remotely from his place would be able to monitor the plant performance. I give you this plant performance analytics case study, wherein in sitting in Gurgaon office, I was able to monitor the plant performance of the water distribution plant in some remote location in Rajasthan. So that is a active and a very relevant example for plant performance analytics. Inventory management, yeah, definitely, like in Amazon. If you have smart sensors into your inventory, you will get a live updates of the capacity which is available for an inbound inventory. Because in this warehouse management, I know how I should know how much space is available to keep the goods. So the parameter which is generally talked in this word is the loading of the warehouse. So if I have a IoT enabled warehouse, I know that my loading percentage is say 80. So I have only 20% capacity available with me. So I can optimize my inventory accordingly as per the loading factor of my warehouse. Smart logistics, of course, smart logistics is happening in Amazon, wherein using smart RFID tags. Different modes are communicating with each other without having human interface. So imagine I have to dispatch from my stock to ship. So, there is a connectivity between the two. So my autonomous vehicle know that the ship is arriving at the dockyard at say around 6 p.m. So my autonomous vehicle is smart enough that is able to collect all the shipments by around 5:30. He knows that from going to my stockyard to the to the area where ship is going to collect the parcel takes say around half an hour. So I need to leave the place by around 5:30. So he leaves the place by 5:30. With Google Maps integration, I know that with the traffics and all, it will take 30, I will be late by 5 minutes. So he intelligently gives that message to the ship that I'll be 5 minutes late. So ship is not really leaving at 6 p.m. but waiting for 5 minutes for the other goods to come. So see, this is happening seamlessly because of the technology. There is no human interface into all this communication. So that is nothing but smart logistics, and that is actually happening in companies like FedEx, DHL, in their European counter organizations. And soon it would be a reality in India. I have absolutely no doubts about it. So so this was more about the key engineering areas wherein we talked about the artificial intelligence applications in device management, in process control, in operations, and now I have around 12 minutes. So in that I would like to touch the point of creative engineering. So creative engineering is also equally important, because the design of your car, the design of your product, the design of your product in sync with the customer requirement is equally important. Today cars don't sell because they have a good horsepower. They don't sell because their engine sound is not there. They are smooth. They don't really sell. I'll say it is a factor, but they don't only sell because their mileage is good. Nowadays the car sells because their HMIs are very upgraded. Their designs are very futuristic. They look very unique. There's a lot of customer study that have been done, and the features are in sync with the customer expectations. So all these things comes under industrial design, wherein industrial design really helps customer develop. It helps customers to develop these brands and products by using design as a strategic tool for business success. And even in our organization, we have found out that using design, we are able to create that differentiation into our engineering products. So design is very important. And design is not only in automotive or transportation. It can be in products, it can be in HMIs, and it can be in industrial service designing. Design means we do design for companies which are producing coolers. Into their we are doing the design of washing machines. We are designing TVs. We are designing microwave ovens. We are designing cars. We are designing shampoo bottles. So the whole point is, design is a very, it's not very vertical specific. Design cuts across various domains. We are designing for healthcare industries. So yeah, so I think this design is very important, and let me tell you that design. There are specific design courses, and designers are not engineers. Designers are people from arts background. But trust me, if there is a lot of demand in the industry for people who are engineers and then they have done some course in design, that's a very deadly combination. Means you have a basic degree in engineering and then you have done some course in design. So you know design and you know engineering. If that is the combination, no, then trust me, there are very good opportunities for students. So what I'm trying to tell here is that post your engineering, it's not necessary that you should only do MTech or you should do MBA, because post graduation in India only means MTech or MBA. No, there is also a third angle to it. If you do some design course, and if you are able to bring some creativity into your engineering domain, then that's a very good combination. There are design studios in IIT Bombay have a course in design, and many of our engineers have done their engineering from from colleges, means non-IIT colleges, and they have done their design course in IIT, and now they are literally they are design heads, design leads, and they are doing very well in our organizations. I know some of the people who are working as the design global design heads in different automotive companies because they have done a course in industrial design, and because such people are not easily available in the market. So imagine a person who have done a course in industrial design now is the global design head for an automotive company. So within a short amount of time, they have got good career growth because they have done a course in industrial design. So I highly recommend people go for an industrial design course if creativity runs in their blood, if they carry that DNA of creativity. And of course, these design have application mainly in HMI domain, and all these higher end cars that you see in India and abroad, all their HMI are being designed by industrial design people, and it is bringing the customer wow factor. And myself was involved in one of the HMI design projects, so this is the outcome of that design projects, and you can really appreciate the infotainment and instrument cluster design that we have prepared, that our designers have prepared, and it's very futuristic, and we have received the design awards for this design. This is the digital mock-up, this AR experience that I have told you that we are developing for one of the rail customers, which would be inaugurated by Mr. Narendra Modi. See, only engineering knowledge would not give will not be able to appreciate the things that goes into creating these digital twins of the physical world if you only know engineering. No, you need to have design engineering course or industrial design course. Then only you would understand to how to do it effectively. Because a train in actual should actually the digital version should look like that. If there is a slight variance, then people will not appreciate. They'll say, "Oh, it's a shoddy work. It is not as close to reality." So whenever there is a virtual or digital twin, it should be as close to as reality. Then only that wow factor is created into the end customer's mind. And digital design engineering, so again I touched upon that these digital technologies and design, when it is combined, it becomes digital design engineering. So I think this is a very good cocktail, I'll say. It's amalgamation of design engineering plus digital engineering plus design engineering. So if people are having such skill set, I think they are creating a differentiator in the market. Lastly, I'll say that there is a lot more to explore in the engineering domain beyond the IT world, and and I think what is really expected from an engineering program is that they are able to apply their knowledge on ground. If they are not able to do that, then I don't think they have gained out of their engineering program. They should really they should have these analytical capabilities. They should have the capability to analyze and interpret and make sense out of data, because data scientist is one of the upcoming areas wherein there is a lot of demand. And while I will say that again, the communication is a very important aspect of an engineer. Trust me, if communication is good, and if they are able to speak their domain language, if they are able to communicate effectively, then they are much more employable, because communication angle is missing in today's engineers. There is absolutely no doubt about it. Then they should engage in a lifelong learning. They should have that attitude that I'm learning to upgrade myself. I'm not learning to to get a job. That's understood. To get a job is understood, but that attitude should be there to gain knowledge. That attitude should not be there that I'm just studying and scoring marks to just get into a a job. Then such people don't end up progressing that far in their career if they don't have that attitude of engaging in lifelong learning. Then they should have a knowledge of contemporary issues. I mean, they should understand the social, economical, legal aspects in addition to technical aspects. Technical should be 80%, but 20% should be legal, economics, and other things. If they are only 100% technical, I'm sorry, these people are not required in the industry. Then of course they should be ability to use technical skills and modern engineering tools. They should have absolutely good knowledge on the digital design and other upcoming technologies. If they are not able to visualize or create any use cases of the engineering, whatever engineering knowledge they have gained, I think then they are not up to the mark, because that's what we see lacking in today's engineers. They are not able to formulate any use case. For example, the use case that I have given for baggage handling system, I think it's a very generic case, and even you don't need to work in industry to come out with that kind of use case. If you are a real engineer and you are observing things on day-to-day life, I think you can come out with this such use cases if you are a good engineer. Yeah. And I think the how we measure outcomes in today's engineering is by merely marks. I think that is a very shrewd way of measuring outcomes. Only judging a good engineer by how much he has scored in a paper, theoretical paper. I honestly, personally, I don't agree with that. So the good measuring outcome should be on the like what he have gained, whether he have gained any experience out of the engineering education, is he able to apply those things in his real life scenarios, whether he was whether when he is thrown into the industry environment, whether he will be able to solve those real life problems. I think that should be the matrix in addition to the marks. Then I think there should be more industry institution interaction, because of which people understand what is required in the industry, and the institution is taking those initiatives to form their curriculum and upgrade their curriculum on yearly basis. So it is very much relevant to the industry requirements. And I think again, the teacher should act as a mentor and help people or students pursue their area of interest. And last but not the least, there is a requirement to establish a process of periodic review of the programs. If you have a periodic review, maybe a quarterly or a half-yearly review, I think then towards the end of the course, people would be in a much better position to implement their learnings. And and another thing, I mean, this on-the-job training. Then understanding the problems. I think this should formulate at least 40% of the total marks. So your theory paper should be only 60%, 40% should be your practical based learning should be there. So I think if we are able to formulate that, I think then we have achieved what is required in the industry from the engineers. So with that, I would like to end my session. I'm happy that I was able to wrap up within the stipulated time, and I sincerely feel that I was able to. I hope, I mean, that I was able to, communicate the relevant experiences from my industry knowledge to the people who have given their precious time for this program. And if you have any queries, I'll be more than happy. And on end note, I would really like to thank the organizers and Vijit sir for considering me to be a part of this session. It was my indeed pleasure and to be a part of it. And I really look forward for such programs in future. And wish you everyone a good weekend. Thank you very much.
So in case if anybody has any queries, you can ask now. Well, I suppose, sir, it was a really a very detailed session. There are no queries as such. So on behalf of Ballarpur Institute of Technology, Ballarpur, And on behalf of the organizing committee of this faculty development program, I would like to thank you, Rohan Dange sir, for the knowledge shared by you. And I suppose that such knowledge which was shared by you was very timely, especially since we are entering in a new growth phase in the segment of, the segment of automation, predictive tools, IoT, and electric vehicles, etc. Suppose, do you have a query?
Actually, it's not a question. I'm from the MBA background, so literally there was no question. But I would like to thank Rohan sir for his patience and lucid insights, clearly explaining all the terms. This was really an enriching experience to me, and I would like to take this opportunity to thank Rohan sir once again. Thank you, sir.
Thanks for your kind words. Made my day. Thank you.
So, Rohan sir, I was saying that the knowledge that was shared by you was very timely because we are entering into a new growth phase in the segment of say automation, predictive tools, IoT, and electrical vehicles, etc. And I must also say that it was a very detailed session on the latest trends in the industry and the future of engineering in the globally competitive environment. The case studies that you have yourself studied and proposed and provided solutions were really fascinating, including that concept of studying the mood of cow and also resolving water supply issue of people from Rajasthan. So thank you for your stimulating address, and we hope that you can join us again, and our students will join this such an interesting sector. So thank you very much once again.
Thanks a lot, Abhijit sir, for your kind words. It really made my day. And again, I have no other words for the, the kind of, good stuff, people have written. It really made my day. I have no other words. Thank you all. Have a good day.
And sir, in the chat box also there is a response from Nikhil Lal sir. He says that thank you for the wonderful session because of lots of case study examples and real time experiences. The session was really good.
Thank you.
Okay. So now I would like to request all the attendees to please fill in the feedback form for this particular session. The link to share the feedback form for this session will be shared shortly on the WhatsApp group. And that is where we say that today the sessions for today are concluded. We will request you to join, all of you can join us tomorrow for the 2 p.m. session. Tomorrow we will have a regular session as the schedule has already been shared with you from 2 p.m. to 7 p.m. and you are requested to kindly join the session by 1:50 p.m. so that we will be able to start at sharp 2 p.m. The link to share the feedback form for this session will remain open only until 11 p.m. tonight. So you are requested to fill in the feedback form prior to that. Thank you so much.
Thanks everyone. Goodbye.
Thank you, sir. Thank you, everyone.